guys, we are going to go through the next part of our notes. You'll notice it's not a new target. It is targets 1 through 3, and this is solving using the method of your choice. That means that you get to decide which method you want to use when solving it. Now, so that means that really our notes for today aren't going to be really that brand new. I'm not going to show you a new method. We're going to stick to graphing, substitution, and elimination, so I'll kind of go through the methods a little bit quicker, but at the same time, it's also a good review of those. But really the main thing I want to talk about is which method might be the best to use when. That's kind of the key, because realistically, when you're solving an application or something with systems, like a teacher's not going to say you must solve this using substitution every time. Really, you're going to want to try and think through, which method might be the best one in this scenario. And sometimes there's more than one pretty decent method that you can use. So that's what we're going to kind of talk about here and kind of decipher between the methods and which one might be the easiest. So if you were to look at a problem and I say, okay, between graphing, substitution, and elimination, really, when I think about solving by graphing, the main things I think about with graphing is if they're in slope-intercept form, so y equals mx plus b form, then if they're both in, or if one is, or it's easy like that, I'm like, let's graph it. That looks pretty easy to graph. Or I might choose to solve by graphing if there is a parabola. Now, that's not always the case. Not all parabolas are easy to graph, and not all of them will intersect at nice integer points. That's the one downfall of graphing, is that if you don't have it intersect in nice points, it kind of defeats the purpose of solving by graphing. So, but otherwise, those are kind of the two main things I would look at for graphing. For substitution, if I were to choose substitution, really if one equation has a variable solved for it already. So one equation has either x equals or a y equals already. That's when I'm going to do substitution. Sometimes I'll also choose to do substitution if it's really, really easy to get that one variable by itself. Then I'll do substitution. Now, elimination is not to say that it's like the last one that I choose, because it's a really great method, but I kind of look for the other two first, and then I'm like, well, okay, it's not easy to do those. That means I'm going to do elimination. Not that it's the longest method, but really I like to choose elimination if maybe both are in standard form. If both are in ax plus by equals c form, then I'll be like, absolutely, I'm going to use elimination. So those are just some things to kind of think about, but they're not always, the end-all be-all of how we choose on these. So let's look at a couple examples. So if I look at number 1 here, really, you could actually choose any of our 3 methods for this one. Pretty equally easy, but there's one that stands out to me the most. Now, I first started to think, okay, well, they're both kind of almost a y equals. Could I put them into slope-intercept form? Yes, but really it takes a little bit more work, especially this one here has a negative. So I'm like, I'm not going to put it in slope-intercept form. Would substitution be pretty easy? Yeah. This variable has the y that's almost by itself, so all you'd have to do is add the 5x over, and then you can sub it in, and that's actually a really quick method. But one thing that stood out to me when I looked at this one is I saw the positive y and the negative y. Those were the only y's in the whole problem, and I'm like, okay, wait. With elimination, our whole goal is to try to eliminate something. You want one to be positive, one to be negative, so when you add them together, they would eliminate. Really, those y's are basically already like that. The only thing we would need to do here is I would need to move the 3x over to put it into standard form. So I'm going to subtract the 3x over. This one already was in standard form. And notice this is actually a really, really easy elimination one, because I don't even have to multiply by anything. My y's are already eliminated here. So that gives me a negative 2x over here is equal to 6. And already we have the x coordinate is negative 3 here. So that was pretty quick. The second step is maybe a little bit longer. You could sub it into, this equation, or the one where you put it in standard form. Again, totally your choice. I'm just going to pick the second one right here. So 6 times negative 3 minus y is equal to 2. Again, this part is no different from anything we've done before. So that's why I'm going a little quicker. We get y is negative 20. So negative 3, negative 20. Again, do you have to do elimination method on this one? This one I did elimination. No, I would say this one wouldn't be that bad to do by either of our three methods. So again, that would be your choice. Now when I look at number 2, for this one, I see right away that this equation stands out. That already has the y by itself, or I'm sorry, the x by itself. So in my mind, I'm like, hey, let's use substitution right away. Could you subtract the 2y over to the left-hand side of the second equation, put it in standard form, and do elimination? Yes, absolutely. Again, I'm not going to say no on that here. But this one stands out to me like, wait, I don't have to do a whole lot of work to get that first step of substitution going. So that's why I'm going to choose substitution to start here. So here I get 8y minus 4y plus 8. Hopefully I don't go too fast here. I sometimes do that. We get 4y is equal to 2, which means y is 1/2. Again, don't get thrown off by getting fractions. Sometimes the fractions are, nice fractions like 1/2. Sometimes they're a little bit messier. You will get fractions from time to time on these for sure. So here we get x is negative 3. So negative 3, positive 1/2. And we have our equation, or our solution here. Again, this one I chose substitution on this one here. All right, let's look at another one here. All right, so when I see number 3, this equation stands out to me right away. That is a parabola. So you have choices here. Could you take this and substitute it in here? Yes, 100% yes. I think that's a great method to do it. But you have another choice here. You also could choose to graph it. I want to show this one by graphing just because it's been a little bit since we've graphed the parabolas. We've done substitution and elimination for a little bit. So I'm going to do that. Could you use elimination on this one? No. When you have an x squared and the other one doesn't have an x squared, we can't use elimination. So you would either do the substitution or graphing. Like I said, I'm going to graph this one. So I'm going to put this one into slope-intercept form. Either way we do it, this one's going to take some work. So we've got y equals x plus 1. This one here, it's in standard form, so I'm going to have to do some completing the square. No, that stuff does not go away here. So here I'm going to have to add 4 to write it as a perfect square trinomial. Here I'm going to add 4. The whole reason of doing this is that factors to x minus 2 times x minus 2, or x minus 2 squared, and we get our vertex form. All right, so I have to graph it. Now we need graph paper. On your homework, I did something kind of similar to this. I, on certain pages, put a little bit, of graph paper. It's going to look like this. Hopefully yours actually looks a little bit neater. Mine, when it converts to a Smart document, doesn't always look great, but I think you can still follow along on yours, and my notes when I print it out will look a little bit better, I think. So here are our first, so this was number 3. We've got y equals x plus 1 was our line, and our parabola was y equals x minus 2 squared minus 3. So let me write that down. Y equals x minus 2 squared minus 3. I'm going to pause my video really quick and get some better graph paper. It is going to bug me here. Hold on. Okay, and I'm back, and I have some better graph paper here. So let's graph both of these. Typically, I a lot of times like to graph my parabola first, so I'm going to go to the right 2 and down 3. Not that it really matters. I just think it's easier to draw a parabola without a bunch of other stuff on there. There's no stretches, compressions, or reflections here, so it's our regular parent function shape. Then I'm going to graph the line. We start up at positive 1. It has a positive 1 slope. My parabola is not great here, but you can see it does intersect at 2 nice points. My green parabola just didn't cross through there all that nicely, so hopefully yours looks neater than mine. So we have one point here at 5, 6. And then we have another point right here at 0, 1. So I'm going to go back and just write those in to here, that we had an solution of 5, 6, and another one at 0, 1. Again, could you have gone through and used substitution? Yes, absolutely. You should get exactly the same answers there. All right, let's look at the next one, number 4 here. So this one, when I look at it, okay, none of them stand out to me right away. So I'm going to put them both into standard form. So I'm going to subtract the 6x. We get 2x minus 3y is negative 10. Here I have to add the 6y. So 3x stays the same. When I add 6y, I get plus 2y. Then subtract the 7, I get a negative 10. So when I look at this one and I look at my x's and my y's, I'm like, well, substitution isn't really easy for either of them. Could we do it? Sure, we're just going to get some fractions, so let's not deal with it. Same with graphing. They're not easy for slope-intercept form. So I would think, all right, let's look at elimination. Now, you could eliminate the x's or you could eliminate the y's. When I look at my y's, I see that we already have one negative and one positive. So I'm like, let's choose to eliminate my y's. Again, is that necessary? No, but that way I don't have to multiply by a negative. So we get 4x minus 6y gives us negative 20. Here we get 9x plus 6y is equal to, that gives us a negative 6. So now we can combine them together here, add them. We get a 13x is equal to negative 26, which means x is equal to negative 2. Now you can choose to sub it into any of those. I probably would not do either of my beginning ones here. I probably would not do the ones that I would multiply. I'm going to probably choose to put it into one of these. I'm just going to go with the second one because that's kind of what I pointed to. But again, it doesn't really matter which one there. That gives us negative 6 plus 2y is negative 2. When I add the 6 and divide by 2, we get a positive 2. So negative 2, positive 2 is our solution for number 4. Again, this one I chose to do elimination here. All right, let's try 2 more here just to again look at them. So when I see number 5, it should stand out to you right away like, ooh, this one is slope-intercept form, and it has a 2/3. Now, again, it's also solved for y. So could you take this and sub it in here? Absolutely. The only thing there is that we have an x plus 2/3 x. It's just a fraction. Could you deal with it? Yes, 100% yes. But when I see this one, I'm like, ooh, this one looks like a really good one to graph, because that one's an easy one to put into slope-intercept form too. So that means I'm going to go back down to my graph paper. We've got 2/3 x, it was 2/3 x, and it was, I think, a minus 5, right? Minus 5, and negative x plus 5. So I'm going to graph them both. I'll start 2/3 x minus 5. And pretty easy one to graph when you already have it in slope-intercept form. And then the next one, we've got positive 5 here and a negative 1 with our slope. And again, it did intersect at a nice integer value. Now, unfortunately, if it does intersect at a value that's not a nice integer value, not going to be our best bet here. So this one did. We're lucky we get a 6, negative 1 here. Again, I did graphing. Again, could you have used substitution? Absolutely. You know what? Let me show you that way just so you can see it. So if I were to put the 2/3 x minus 5 in for that y, we get this. Now again, could you add x plus 2/3 x? Yes. Sometimes what I like to do in this scenario, though, is get rid of the fraction. If you remember way back to first semester, if you multiply everything through by that denominator, that have to multiply that, that gets rid of the fraction, and then it's maybe a little bit easier to solve. So we get 5x minus 15 is 15. 5x is 30, which means x is 6. Substitute it back in. I'm going to do it into the x plus y equals 5. So 6 plus y is 5, which means, again, y is negative 1. Notice we get the same answer. So this is our substitution, and then the upper one is graphing. Some people think one way is easier than another. Again, I would say it doesn't really matter there. All right, last one to look at. Again, oops, sorry, when I look at this one, I look for things that might make it easy. Now, neither of them are in standard form, so right away we could do that if we wanted to. But what stands out to me instead of doing standard form is this kind of lonely little y in the second equation here. That y is already almost by itself. So when I look at this, I'm like, what if I just subtract that 7x and we have that by itself? Now, again, would it have been just as easy to subtract 2x? Sure. But then I would have to subtract 3y as well, and then I'd have to go through the whole process of elimination. If I did this, I thought that's pretty easy to do substitution. Now, again, is it required to do substitution? No, absolutely not. This is where you have a chance to choose whichever method is your favorite here. So just don't go too fast. I tend to go too fast on these, like right now, and that gives us x is equal to 1. Sub it back in, negative 5 times 1 plus 4, or negative 1. So we get positive 1, negative 1 here. All right, as you go through the homework, again, pick which method is your best method. Which one makes most sense in this scenario? When you go through my homework, and I'll write this in like my answer key to the homework when I post it on Thursday, you'll notice that I actually ended up choosing a couple different methods just so I could show you some different work. Because again, there's not always one right way to do a problem. There is only one correct solution, but the method of getting there can vary. So again, it just kind of depends on what you think is the easiest one to do. So as always, let me know if there's any questions, and I hope you guys are doing well. Thanks. Bye.